So what happens if light doesn't just pass straight through a material? Well, then it can get absorbed and or re-emitted. An extreme case of that is a mirror. So in a mirror, you've got glass where light just passes through, and you've got a silver surface where light is bouncing off, and so it's being absorbed and re-emitted. And you can see, because the image is so clear, that the angles of incidence and the angles of reflection are very well controlled. Otherwise, the image will be all scrambled. And indeed, it's very easy to show that in reflection, the angle of incidence is exactly equal to the angle of reflection. So if you have the normal to the surface and your angle, your line of incidence coming in there, then that defines a plane, and then it bounces off at exactly the same angle in that same plane. The plane is called the plane of incidence, and the angle of incidence and the angle of reflection are equal. So we'll use I for the incidence and R for the reflection. And this exact same behavior is also what you tend to see if you have something like a ball bouncing off a wall. And so if you have something that's conserving its energy as it bounces off, there's no particular friction to that surface, then you tend to get things bouncing off with the angle of incidence being the angle of reflection as well. And that's what happens for light. Or indeed, it happens for light for certain kinds of surfaces. So for some silvered surfaces, we've got a silvered surface in this mirror here and a silver surface, just a piece of alfoil. And you can see there's no beautiful image here. So the angle of incidence isn't quite equal to the angle of reflection. Or maybe that's not quite true, because you can see that this surface is very rough. And so maybe on every small little piece of that, where the angle is different, maybe the angle of incidence and the angle of reflection is the same, but over a whole surface like that, what happens is you have some light rays coming in, they scatter off in lots of different directions, because the surface is in lots of different directions. And so this is called a diffuse reflection, and this is called a specular reflection. And then finally, we have interaction between light and matter, where it's not simply absorbing and re-emitting as almost one process, but it's actually a bit more complicated than that, and that's with absorption of other kinds. So look at this surface here. It's yellow. It's yellow because it's mainly reflecting the yellow light. Okay, so it's not reflecting all the frequencies or all the colors, it's just reflecting the yellow ones. And it's bouncing off, and you can see I can't see a sort of yellowish image of me reflected in here. So what that means is it's quite diffuse. What's happening to all the other frequencies? What's happening to all the other colors? Well, they're being absorbed, and that energy isn't immediately going back out as light. That energy is being shared around amongst the molecules and going into a whole bunch of different areas, and eventually that comes out as heat, or indeed infrared light. So if you shine a lamp on this, the yellow frequencies bounce off, and the others eventually just heat the thing up, and it comes off as other frequencies. So normally, if you want to see something that exhibits lovely specular reflection, you have to make it deliberately to do so. Most things, the yellow cardboard, me, the desk, the chair, they all have diffuse reflection and mainly absorption of lots of other colors, and so the light just comes off them, gently bounced off some light source. Something like the screen that you're looking at now is making its own light, which it's setting out, but normally this is the kind of behavior you get. Now, if you do see specular reflection, it's either because you're looking at a very still pool of water or something like that, or else you've deliberately made a mirror. And people also deliberately make things that change the direction of light, for example, lenses. So anytime you use glass or mirrors to manipulate images in particular ways, those things are called optics. And from Snell's law and from the law of reflection, we can figure out how to build optics, how to build things that control the path that light takes.